This next example is vector components with just a flavor of forces. I have a situation where I have a block of mass m with some force, 12 newtons, applied at an angle of 36 degrees. And that mass on my block is 14 kilograms. I want to apply some mystery second force that creates an acceleration of 0.4 meters per second squared in the x direction only. So I know it's not just this force causing it, because this force would cause an x and y acceleration if applied alone. So I'm going to apply some mystery second force that creates this acceleration. Now, because forces and acceleration have been mentioned, hopefully your brain has triggered F net equals ma. And in fact, we could go ahead and figure out what our net force needs to be with the information given. So that would be mass of 14 kilograms and an acceleration of 0.4 meters per second squared in the x direction. And I get out 5.6 newtons in the x direction. So notice that the direction carried through the multiplication there. A handy trick of Cartesian coordinates is that I can worry about x and y separately. So I can worry about the sum of forces in x and the sum of forces in y separately. And think about this. This would be net force in x and net force in y. Well, there is no y acceleration, so I know some of my net forces in y will be 0. And we just found that there's only x force, so some of my net forces, or some of my forces in x must be 5.6 newtons, and we've already worried about the direction over here. So I'm going to add some second vector to this one. And we're going to do this in x and y components. So let's go ahead and decompose this vector into its x and y components. So force 1x. X is adjacent to this, so that would be F1 cosine theta. And that's 12 newtons cosine 36 degrees. And if I grab a handy dandy calculator, I get 9.7 newtons. F1y, y is opposite, so if I drew the y vector there to complete the triangle, F1y, F1 sine theta, 12 newtons cosine, opposite, 36 degrees, and I get 7.05 newtons. Well, this makes the y part really easy. If we look over here, sum of forces in y is 0. So if F1y is 7.05 newtons, then F2y must be exactly opposite that. So think about this. I know my sum of forces in y is 0, and that's y1 plus y2, which is 7.05 newtons plus F2y. Remember, that's equal to 0. So F2y is negative 7.05 newtons, which would mean 7.05 pointed this way. So I'll just draw that vector component. F2y equals 7.05 newtons, negative. Okay, F2x is just one more step more complicated. So sum of forces in x is 5.6 newtons from here, which would be getting ahead of myself, F1x plus F2x, which means 5.6 newtons equals F1x, 9.7 newtons, plus F2x. And if I solve this for F2x, I get F2 negative 4.1 newtons. That would be negative x, so if I draw that vector component, F2x equals negative 4.1 newtons. And the resultant vector will be a little more negative y than it is negative x. If I wanted to draw that, I would take these two vectors and add them together. That is my F2.